This is the AP Calculus 5.5 and 5.8 review, problem number 1. All right, in problem number 1, we are asked to use a substitution to evaluate the integral. Notice that this is an indefinite integral. We do not have limits of integration on our integration symbol, so that means that we need to remember our plus c after we're done finding our antiderivative. All right, now I know that since I have x cubed times secant squared of 5x to the fourth, I'm definitely going to want to use u substitution for this problem. And since the derivative of 5x to the fourth would be something x cubed, then I want to let u be 5x to the fourth in this problem. Then my du dx, bring down the 4 times 5 is 20x cubed. Okay, now if I rearrange my integral a little bit here so that I can see the different pieces of it, I'm going to move that secant squared of 5x to the fourth first, and then I'm going to put the x cubed dx second. So again, I'm trying to find a match for x cubed dx. So when I go back over here to my du dx equals 20x cubed, I want the x cubed, and I want dx over there with it, so I'm going to multiply both sides by dx, but I'm going to divide both sides by 20. So I'm going to get du over 20 is equal to x cubed dx. So that tells me that over here, for my x cubed dx, I am going to substitute in du over 20. And then my 5x to the fourth is my u, so this part of my integral is going to become secant squared of u. And of course, since I'm dividing by 20, I can pull that in front of my integral symbol. So I'm going to have 1 over 20 times the integral of secant squared u du. And now, if I'm trying to find the antiderivative of secant squared, I just have to think to myself, what is secant squared the derivative of? And the answer is, secant squared is the derivative of tangent. So my antiderivative here is going to be 1 over 20 times tangent u plus c. And then the last step obviously would be to switch back to x, so I have to substitute back in what I let u represent, which was my 5x to the fourth. So my final answer here is going to be 1 over 20 tangent of 5x to the fourth power plus c. This is the answer to my integral. In problem number 2, I have 4 times e to the x minus 7. And typically whenever we have a problem where we have e to a power, if we have a function in our exponent, that's usually what we let our u be. So for this problem, I am going to try letting u be x minus 7. Then my du dx is just going to be equal to the derivative of that. Well, the derivative of x is 1. The derivative of negative 7 is 0. And so I just need a match here for my dx. So if I multiply both sides by dx, I get du is equal to dx, because 1 times dx is just dx. So I get to substitute my du in here. The 4 can actually come out in front of my integral. And then I just have e to the u times du. And I know that the derivative of e to the u is e to the u, so I know that the integral of e to the u is e to the u. So this is just going to be 4 times e to the u plus c, and then I have to substitute back in what u was, which was my x minus 7. So my final answer is just 4 times e to the x minus 7 power plus c. In example number 3, I'm starting with, first of all, an integral that has limits of integration on it. So in this problem, I should get a number answer when I am done. And this is because I have limits of integration. Okay, so keep in mind when we are finished, we should have a number answer here, not something plus, not a function plus c. Okay, because we're going to evaluate it at e and evaluate it at 1. All right, now the first thing that might be confusing things or complicating it in your brain is this 5 and this 3. And we know that coefficients can always get moved in front of the integral, okay? So the first thing that I'm going to do is I'm going to rewrite this as 5/3 times the integral from 1 to e. And then I'm going to separate. I have that x on the bottom, so I'm going to write my ln x, which is in my numerator, times 1 over x dx, because that x is in my denominator. And again, when I think about what I want to let u be, I always want to choose u so that, if possible, the derivative of u is part of my integral. So if I let u be ln x, the derivative of natural log x is 1 over x, which is part of my integral. So that's actually going to work out nicely. So I am going to let u be natural log x. Then du dx is equal to 1 over x, and du is going to be equal to 1 over x times dx. So my substitution right here, my 1 over x dx, is going to be my du. And my natural log x is what I let u equal, so this is just my u. So now I am integrating 5/3 times the integral of u du, which is just a polynomial, right? This is u to the first power. So if I'm finding the antiderivative of that, I am going to add 1 to my exponent, so it will become u squared. But then I have to multiply in front by the reciprocal of 2, which means I need a 1/2 there. And then I know that I'm going to be evaluating this on my limits of integration, but notice I haven't been writing them because right now I'm in u form, and so I'm going to wait until I switch back to x form. So let me just simplify this one more time here. 5/3 times 1/2 is going to be 5/6, and then u was natural log x, and that's squared, and I am evaluating this from 1 to e. So now I'm going to go ahead and evaluate this. So I'm going to get 5/6 times natural log of e squared minus 5/6 times natural log of e to the first power. Well, natural log of e is log base e of e, which is just 1. So 1 squared is 1. 5/6 times 1 is 5/6. And then here, natural log e, again, is 1. 1 to the first power is 1. And so I end up with, oh, I'm sorry. I made a little mistake here. I was supposed to plug in 1, not e, natural log 1. There we go. Sorry about that. So natural log of 1 is 0. Okay, and then 0 squared is 0. 0 times negative 5/6 is 0. So I end up with 5/6 minus 0, which gives me an answer of 5/6. So there's my answer for problem number 3. And then problem number 4, we have cosine to the 4th power of x times sine of x dx. And again, a definite integral here. We have limits of integration on our integration symbol. So when we are done, we should have a number answer, because we will have to plug in those limits of integration. And again, we want to be thinking about, okay, well, I would like whatever I let u equal, I would like the derivative of u to be part of my function. So since I have cosine to the 4th power, it probably makes sense if I let u be cosine x, because the derivative of cosine is negative sine x. I have that sine x dx. I could just pull the negative in front of the integral symbol, so that should work out. So let's try that. I'm going to let u be cos x. So then du dx, derivative of cosine is negative sine x. And again, I could multiply both sides by dx and divide both sides by negative 1. So I get negative du is equal to sine x dx, which is what I'm trying to match with over here. So I know that this part is equal to negative du. And then if I let u be cosine x, if I have cosine to the 4th power of x, this is just going to be u to the 4th power. So I'm going to pull my negative sign out in front of my integral. So I have negative the integral of u to the 4th du. And now I just have to integrate this. So I add 1 to my exponent, so I'm going to have u to the 5th, but then I have to multiply by the reciprocal in front. So I will have negative 1/5 u to the 5th. And again, I'm evaluating this on my limits of integration, but in terms of x. So now I'm going to switch back to x. And when I do so, then I'm going to have negative 1/5. And then again, u is cosine x. So this is cosine x to the 5th power. And I'm going to write it like that. Usually we write it as cosine to the 5th power of x, but I'm going to leave it in the parentheses for substitution purposes. And I'm going to be evaluating this from pi over 6 to pi over 4. So when I plug this in to evaluate, I'm going to get negative 1/5 times cosine of pi over 4 to the 5th power minus negative 1/5 times cosine of pi over 6 to the 5th power. Start on the inside, work your way out. PEMDAS. Cosine of pi over 4 is square root of 2 over 2. So I have negative 1/5 times the square root of 2 over 2 to the 5th power. Minus a negative here, chop chop, that's going to be plus. Cosine of pi over 6 is square root of 3 over 2. Whoops. Oh boy. I'm not sure how to get rid of that. Plus, here's my 1/5. Just ignore that right there. And then again, square root of 3 over 2. Okay. So as an exact answer here, certainly we could distribute our 5th power there to the numerator and the denominator in both of our fractions on the left and on the right. But at this point, I just estimated my answer with a decimal. Okay, so at this point, if you plug this in your calculator, this is approximately equal to 0.062. Okay, but of course, you could do square root of 5 times itself 5 times, which is going to give you 4 square roots of 2, and then 2 to the 5th would be 32, so you could certainly simplify that. And then square root of 3 to the 5th power is going to be 9 square roots of 3 over 32, again times 1/5. You could simplify that and leave it as an exact answer, but I approximated with a decimal on this one.